Here we are going to learn how the Zener diode it acts as a voltage regulator. In this circuit, that Zener diode it plays a vital role. There in the circuit, there the input voltage is given, that is given in the form of DC. There the input voltage that can be varied by varying the dial. Okay. Here you are able to get the constant output voltage. The power supply what is given here is called unregulated power supply. That unregulated power supply can be converted into a regulated power supply. That's why this is called as voltage regulator. Though if you vary the input voltage, you will be getting the constant output voltage. Here I would like to get the 6 volt as output. That's why I have preferred the Zener diode with Zener breakdown voltage of 6 volt. In market, Zener diodes are available with different breakdown voltages. 6 volt Zener diode is available, 12 volt Zener diode is available, 4.7 volt Zener diode is available. Depends on the need, you have to prefer. Here I would like to get the output of 6 volt. That's why I have bought the Zener diode of breakdown voltage 6 volt. If the Zener breakdown voltage is 6 volt means the output also will be 6 volt DC. So across the two terminal, the output voltage it won't vary, it remains constant. Now we are going to learn how the things are working, clear, what are the resistances are there, how the current is flowing, all those things to be analyzed. Here first we have to start some reference point. Let us imagine 15 volt input voltage is applied. That's why in the middle I have written. So 15 volt input DC voltage is applied across the two terminal. Here one resistance is there, the name of the resistance is called series resistance, otherwise it is also called as current limiting resistance. The value of the RS is taken as 2 kilo ohm. Here to get the output, here in the output region one more resistance is connected, that is load resistance, its value is 3 kilo ohm. Are you clear? The current which is passing through IL, the current which is passing through RL is called IL, load current. Are you clear? This is called load resistance. The current which is passing through RL is called load current. Are you clear? The current which is passing through the Zener diode is called, what is this? IZ, Zener current. Are you clear? So don't forget, the clear, three currents are there. If you add this IZ and IL, if the Zener current and load current, if both are added, you will get total current I. So the current which is passing through RS series resistance is called total current. So we'll calculate everything methodically. Are you clear? Later we'll go for two more cases. So as an initial stage, while starting to compare the case 1 and case 2, what we have to do? We need some reference. That's why I have given the DC input of 15 volt. So what is the input voltage given in the circuit? 15 volt DC is given. Are you clear? How much, what is the Zener breakdown voltage here? 6 volt. So by knowing 6 volt, by knowing this 15 volt input voltage, we are able to calculate the VRS. What is VRS? VRS means voltage across RS can be easily found out. 15 volt minus 6 volt is clear to be calculated. So VDC is how much? 15 volt minus Zener breakdown voltage is 6 volt. That itself is the output voltage. VZ and VO both are same. Therefore 15 volt minus 6 volt is equal to how much? 9 volt. So 9 volt voltage drop, the clear, can be measured here. Are you clear? What would be the voltage drop across RS? The voltage drop across RS is 9 volt. That you have to easily, that you can easily calculate. The next one is, I would like to calculate the total current. So I know the value of 9 volt, that is VRS, and RS is already finalized, that is 2 kilo ohm series resistance. By knowing 9 volt and 2 kilo ohm, the total current I can be easily calculated by Ohm's law. So what is the value of VRS? VRS is equal to 9 volt divided by RS value is 2 kilo ohm. 2 kilo ohm can be written as 2000 ohm. How much? 2000 ohm. 9 volt divided by 2000 ohm is equal to 0.0045 ampere. That can be simply written as 4.5 milliampere. So at present, how much amount of current is flowing through the RS? 4.5 milliampere is flowing. 4.5 milliampere amount of current is flowing through RS. Any doubt in this? Okay. Next we will calculate the current which is passing through RL. Very easy. Already I have told, this is clear, we are able to get the 6 volt as output, constant output voltage. Therefore 6 volt is known. Are you clear? So IL can be easily calculated. So VO is equal to 6 volt divided by load resistance value is 3 kilo ohm. So 3 kilo ohm can be written as 3000 ohm. 6 volt divided by 3000 ohm will be equal to how much? 0.002. 0.002 ampere, which is equal to 2 milliampere. 2 milliampere is the current which is passing through load. So this is nothing but IL. So IL can be written as how much? 2 milliampere. 2 milliampere. Here 4.5 milliampere is flowing, here 2 milliampere is flowing. By knowing these two current, which one can be calculated? With the help of Kirchhoff's law, we are able to calculate IZ. IZ is nothing but total current minus IL. Therefore 4.5 minus 2 is equal to how much? Substitute here. 4.5 milliampere minus 2 milliampere will be equivalent to 2.5 milliampere. So this is the value of IZ. So I will write it here. 2.5 milliampere amount of current is flowing through Zener diode. Are you clear? And then finally you will be getting the constant output voltage 6 volt here. That is not going to be varied, because Zener breakdown voltage is how much? 6 volt. Same thing you will get. So this is the thing which is written as the reference point. Are you clear? Next I am going to increase the VDC. VDC means input DC voltage to be either increased or decreased. The next case I am going to increase the input voltage. Then what are the things are happening? How the currents are varying? Which current is constant? Which current is not changing? All those things can be found out one by one. This is the total current. This is the load current passing through resistance. This is IZ. What is IZ? Current passing through Zener diode. Make a note. Output voltage is how much? 6 volt. The input what you are supplying across the two end is 15 volt. The output what you are getting across the RL is 6 volt. Now we have to prove that whatever may be the input voltage VDC, the final output voltage is a constant one. So very interesting one. In the textbook everything is given in the form of sentences, but here we are learning everything in the form of numerals. Are you clear? Now we are going to learn the case 1. What we are going to learn in the case 1, here I am going to increase the supply voltage, the input voltage DC voltage to be increased from 15 volt to 18 volt. What are the changes are happening one by one that we have to analyze? Already I have told, to calculate the voltage drop across these two end, you can use this formula. What is VRS? VRS is equal to VDC minus VZ. The new input voltage, increased input voltage is 18 volt. So therefore, VRS, voltage across VRS is equal to voltage drop across RS is equal to VDC 18 volt minus how much? 6 volt is equal to 18 minus 6 is equal to 12 volt. Here what happened? Compared to this 9 volt, here the voltage drop across RS is increased. Voltage drop across RS is increased. Next one is I am going to calculate the current. I am going to calculate the current which is passing through the RS. What is the formula? Here VRS. VRS is voltage drop across RS divided by series resistance. Substitute 12 volt divided by 2 kilo ohm. 2 kilo ohm is nothing but 2000 ohm. 12 volt divided by 2000 ohm is equal to 0.006. 0.006 ampere. 0.006 ampere can be written as 6 milliampere. Are you clear? 6 milliampere. Look at here. The total current in the previous case is 4.5 milliampere. Now it becomes 6 milliampere. So I have to write here 6 milliampere. Are you clear? When compared to the previous case, after increasing the input voltage, which one also increases? The total current also increases. Are you clear? VRS is also increased, total current also increases. Next we will calculate the current which is passing through IL. Will there be any change? There won't be any change at all because you will be getting the constant output voltage 6 volt divided by RL. How much? 3000 ohm. Again you will be getting 0.002 ampere, which is equal to 2 milliampere. So there is no change in the current which is flowing through load resistance. IL remains same, no change. Already when the input voltage was given 15 volt, no, then also the current passing through the load resistance is 2.5 milliampere, 2 milliampere, now also 2 milliampere. No change in both the two cases. Now we will calculate, is there any change in the Zener current? How to calculate the Zener current? IZ is equal to IRS. What is the amount of current which is passing through RS? 6 milliampere total current. 6 milliampere minus, and then IL value is 2 milliampere. So 6 milliampere divided by 2 milliampere is equal to 4 milliampere. Look at here, when compared to the previous case, when the input was given as 15 volt, the current passing through the Zener diode is 2.5 milliampere. Now the Zener current is increased. Are you clear? Zener current is increased. No change in the current which is passing through the load. Total current is increased. Are you clear? No change in the which current? The current which is passing through the load. Again, is it clear? The output voltage will be how much? 6 volt. No change in the output voltage. Though, is it clear? The voltage is increased. Again, you are getting the constant output voltage. Are you clear? Because that Zener that works in the breakdown region. When it is working in the breakdown region, what happens? The current which is passing through IZ will be how much now? 4 milliampere. IZ value is 4 milliampere. Are you clear? So 6 milliampere minus 4 milliampere will be equal to 2 milliampere. 2 milliampere. 2 milliampere into 3 kilo ohm is equal to how much? 6 volt. Again the output voltage is remaining same. Are you clear? Case 1 is clear, learnt. Case 1 is verified. Are you clear? Now we are going to learn the second case. Now we are going to see the case 2. In case 2, we are going to decrease the input voltage. By dialing this knob here, we are able to decrease the input DC voltage. So compared to the reference value, now the voltage is reduced to 11 volt. In the input voltage is 11 volt. We will see how the constant output voltage is obtained at the end. Now we have to calculate the voltage drop across RS. How to calculate? Very simple one. The formula is VRS is equal to the input voltage minus the Zener breakdown voltage. So how to calculate this? Substitute here. Voltage drop across RS is equal to 11 volt minus 6 volt is equal to 5 volt. 5 volt. Are you clear? So now look at the voltage drop. What happened compared to this value? Compared to this value, the voltage drop across RS is reduced. The voltage drop across RS is reduced. Now we are going to calculate how much amount of current is flowing through the RS, that is total current. How to calculate this? I is equal to 5 volt and then resistance value is 2 kilo ohm, that can be written as 2000 ohm. 5 volt divided by 2000 is how much? 0.0025. 0.0025 ampere, that can be written as 2.5 milliampere. 2.5 milliampere. So here through the RS, 2.5 milliampere amount of current is flowing. 2.5 milliampere amount of current is flowing. Now we are going to calculate the current which is passing through the load. That's very simple. Since the Zener breakdown voltage is 6 volt, the output also will be equal to how much? 6 volt, because it is working in the breakdown region. Now IL will be equal to, what is the value of IL? 6 volt divided by 3000 ohm, which is equal to 0.002 ampere, which is equal to 2 milliampere. So 2 milliampere amount of current is flowing through the load resistance. Are you clear? Don't forget. 2 here IL must be written. I is equal to 2 milliampere. So this is the current. Look at in all cases. In the first case, reference case also, we have obtained IL value as 2 milliampere. When the voltage is increased, then also the current passing through the load is how much? 2 milliampere. Now the voltage, input voltage is decreased, then also the current passing through load resistance is 2 milliampere. In all the three cases, same amount of current flows through the RL. Are you clear? Since the constant current is flowing, 2 into 3 kilo ohm. As per Ohm's law, we have to write. How to obtain the formula? VO is equal to the load current into RL. Both of them must be constant. Only then you will get the constant output voltage. IL is 2 milliampere and RL is 3 kilo ohm. If you multiply both, you will get 6 volt. Make a note. Constant current is flowing. Now we will calculate about the Zener current. How to calculate Zener current? Very easy. IZ is equal to, now by using Kirchhoff's law, I minus IL. So what is the value of I? 2.5. 2.5 milliampere. 2.5 milliampere. And then what about IL? IL is 2 milliampere minus 2 milliampere, which is equal to, what is the value? 0.5 milliampere. Now look at the value of Zener current. Are you clear? Now the Zener current, compared to this value, Zener current is decreased. Zener current decreases. Zener current value is how much? 0.5 milliampere. When the input voltage is decreased, Zener current also decreases. Are you clear? Zener current decreases and then total current decreases. Are you clear? And voltage drop across RS is also decreased. Make a note. With the help of this reference line, reference values, we are saying basically which one increases and which one decreases. When VDC is decreased, input voltage is decreased, which one decreases? Current passing through Zener decreases. The total current also thereby decreasing. Are you clear? The potential drop across RS is also decreased. But the current passing through IL, the current passing through RL, that is IL, is constant. So constant current is flowing through the resistance. If you multiply these two values, you will get how much? 6 volt. Are you clear? Always the output voltage will be 6 volt. Therefore, though the input is changed, are you clear? Whatever may be the input value, if you vary this input voltage, you will be getting the constant output voltage. Are you clear? So the output voltage, what you have, what you want to apply, what you want to get, what you want to finally arrive, exactly, that is purely determined by Zener breakdown voltage. That is very important. According to that, we have to fix the value of RL and RS. We have to choose the right kind of load resistance and right kind of series resistance must be selected. To select RS and RL, formulas are available. Are you clear? So right amount of, right value of RS and RL must be chosen, and the output what you want to get finally, that is purely determined by Zener breakdown voltage. In this case, I have taken the Zener breakdown voltage as 6 volt. That's why I am getting the output value of 6 volt. So though the input voltages are varied, I am getting the constant output voltage finally. So that is a function of Zener diode, clear, as a voltage regulator. So in voltage regulator circuit, Zener diode, it plays a vital role. Okay, that's why we are saying that Zener diode as a voltage regulator. I hope you may have understood. Okay, thank you.